given that we have an angle in quadrant 3 whose cotangent is 5/2, and we have another angle in what looks like quadrant 4 whose tangent is -6, we want to determine the exact value of secant of the difference of these angles. Okay, secant of theta minus beta. So you might not know what the secant summation identity is. That's fine. There isn't really one. Instead, what we're going to do is we're going to say secant is equal to 1 over cosine, right? That is our basic reciprocal identity. And it doesn't matter what the angle is, this will always be true, which means the angle can even be something crazy like theta minus beta. And you just keep that angle the same in both places, theta minus beta. So if we can find what cosine of theta minus beta is, we can very easily turn that into secant of theta minus beta. And to do this, I'm going to use two triangles, our usual procedure here. And it looks like that first one is in quadrant 3. So I'm going to draw myself a quadrant 3 triangle right here. Does not need to be accurate. There's theta, and I know that the cotangent of theta is 5/2. Well, what's cotangent? It's adjacent over opposites. Okay, it's a good time to review your SOHCAHTOA ratios. So adjacent over opposite, that means 5/2. And you might be feeling good about this, but hold on a second. This is quadrant 3. Those values are supposed to be negative. So that's -5 and -2, according to the directions on the coordinate plane. And just double check the ratio. -5 over -2, that's the same as 5/2, right? So we are good. And we just need to figure out the hypotenuse of this triangle. Well, looks like we're going to have square root of 29 for this guy. Okay, that one's done. Move on to beta, which is in quadrant 4. So I'm just going to give myself a little more room here for this triangle. There's my quadrant 4 triangle. Tangent is -6. Okay, here's my reference angle right there. Tangent is opposite over adjacent, so that means -6/1. I double check the signs. This makes sense. -6 is the part going down, +1 is the part going to the right, so that looks good. And now I just need to do a Pythagorean theorem argument over here, and I get square root of 37 as the hypotenuse. So now we are set to go. Let's just remind ourselves of what the cosine identity is for the difference of two angles. Cosine of theta minus beta equals cosine of theta times cosine of beta. Now cosine changes the silly sign, so that minus becomes a plus. And now it's sine theta, sine beta. So now we just plug in the values according to these coordinate planes. Theta is the triangle on the left, the red one. Cosine of theta is adjacent. That's -5 over hypotenuse. That's radical 29. And sine of theta is opposite, -2 over radical 29. Okay, then we have the beta triangle, the right one, the blue coordinate plane here. Cosine of beta in this case is adjacent. That's 1 over square root 37. And then sine of beta is the opposite. That's -6, opposite side, over square root of 37. And don't forget we have that plus sign in the middle. So sort that all out, and what do we get? Well, on bottom, we have this really ugly denominator, which is 29 times 37 in a square root. We'll need to sort that out. Maybe. Maybe not. -5 times 1 is -5. -2 times -6 is just 12. So I can call this, what is this? Just 7 over... Can we simplify that? Let's see. No, we can't simplify that. That's just going to be 1073. There are no factors in here that are themselves square rootable. Is that a word? Right? 29 and 37 can't be square rooted, so their product can't be square rooted either. So this is cosine of the difference of the angles. That means secant of theta minus beta is just that fraction flipped. So 1073, square root of that, all divided by 7. This would be our answer. All right?